Good day. So I want to go over some of the insulation stuff with you. So we've had 3 tests. Wall insulation values 1 is closed now. Wall insulations 2 is closing tonight at midnight. So I want to go ahead and go over the wall insulation values test 1 with you. And I'm going to open up the R value table, and I need to open up my calculator. Alright, so everybody's done really well on this. I think some of you guys you just kind of missed a couple of things, maybe overlooked or overthought it. So that's why I want to kind of go over stuff with you. So according to the manufacturer, R19 is only true if the wall is blank inches wide. Well, you're going to have to go over here and find a manufacturer. I just basically went to Lowe's and type in R19 bad insulation. And we have John Mansfield. So let's click on that. It tells us that it is an R19. And if we look in the specifications down here, maybe R value per inch 2.923. That's one indication that we could go by. Thickness is 6.5 inches. All right, for R19, maximum value R19, fits in a 2x6 wall. So let's pull up the old handy dandy calculator here and say 2.923. Actually, let's go a different way. Let's say R19 divided by 2.923 equals 5.5 inches. Okay, and I gave a little leadway on that, so if you put 6, that's fine. Nevertheless, what I wanted you guys to understand is this is a little bit confusing. All right, yes, we use this for a 2x6 wall, but we can only get R19 if we have a full 6 to 6.5 inches of space there. And a 2x6 stud, is only 5.5 inches wide. Next question, number 11. Now, these are the most missed questions that I'm going over. I'm not going over the ones that everybody got right. So, the cavity of an 8-inch CMU, which is 5.5 inches wide, are poured with vermiculite. Adding the R for the block and the vermiculite, what is the theoretical total R value? All right. For some of you guys who are not familiar with vermiculite, let me explain to you what vermiculite is. I don't know if I went over that before or not. So vermiculite and perlite are both a mineral that is mined, and this is what vermiculite looks like. It's almost like cork looking stuff, but it is very light and it has a little bit of an R value to it. Let's look at perlite. Perlite is very much similar. Look at there, we got a picture of the two together, which is nice. Come on, open up for me. There we go. So we've got vermiculite and perlite. Both are a mineral and both have insulation properties. You see perlite and vermiculite a lot in soils. If you buy potting soil, that's what you'll see right there. The white is perlite and the vermiculite is the brown, or in the brown you can see the perlite versus the vermiculite. If you want to do some research on the differences, is definitely knock yourself out and use that. But for the most part, let me explain a CMU and what we do with that perlite. So in the CMU, look at there, CMU. Let's try concrete masonry unit. There we go. All right, so what we do is we take this block here, and in a block wall, they'll fill this full of vermiculite or perlite. It helps a little bit through here, but it doesn't help through this thermal bridge here, and that's where we end up with some problems. So let's go over to our chart and let's find vermiculite. So we've got insulation materials. We have vermiculite right there at 2.13. So 2.13 times 5 inches equals 10.25. So what is the block? The block itself, and let's see, probably in construction materials. Nope. Poured concrete block. Did I say what size? 8 inch. Yes, I did. Okay. So 8 inch concrete block gives us a 1.11. So I'm going to add 1.11 to that to end up with 11.76. And 11.76 is the right answer. Good going, Mark Anderson. Next, a 2x4's R value is blank across the 3.5 inch side. Here's where I think some of you overthought it or didn't think hard enough or what. I'm not rightly sure about that. So let's take a look at this, and so we can understand what's going on here. So I'm going to draw a 2x4 and a 2x6. This is an inch and a half inch, an inch and a half wide here and an inch and a half wide here. This is 3.5 inches and this is 5.5 inches. All right, so a 2x4 is not 2x4. It's actually 1.5 by 3.5. A 2x6 is not 2x6. It's 1.5 by 5.5. Let's keep that in the same 5.5. Now, when I was asking what is the R value of a 2x4 across the 1.5 inch side, I'm wanting to know this, all right? What's the R value there? What is that? So let's find out. Go over here to the, well, oh, because I got my pen laying there. Go over here and we have and let me make sure I understand the question. Across the 3.5 inch side, I'm sorry I lied to you. I have lost that thing. If I turn it off, it goes away, bad jingoes. All right, so I lied to you. I'm looking for the 3.5 inch side, all right? What is the R value there? 3.5 inch is equal to R dang it if I quit laying my pen down. All right, so 3.5, 2x4, 3.5 inch is 4.38. All right, so we're going to write that down. 4.38. Now let's really think about this. If we have wood, let's say, let's start right there, wood is equal to 1.25 per inch. All right, if we say 3.5 inches times 1.25, we actually end up with 4.375. They just round this off to 2 decimal points, and that's fine. So the next question was, what a 2x6 value, what is it across the 5.5 inch side? All right, right there we have it. 5.5 inch 2x6, 6.88. Okay. And then what is the 2x6 R value across the 1.5 inch side? Well, both a 2x4 and a 2x6 are going to have the same, nominal 2.5 inch or 2 inch, 1.5 inch. So the answer to that question is 1.88. A lot of you ended up with that backwards. So make sure that across 1.5 inches, what's 1.5 inches? 1.88. What is the total R value of a wall made from 12-inch CMUs, 1-inch airspace, and a 4-inch face brick? Let's go and write that down here. "12-inch CMU, 1-inch air, and 4-inch face brick." Okay, all we got to do is find out what our stuff here is, the R values for that. We have a 12-inch concrete block here at 1.28. We have an airspace. You go all the way down here at the bottom. Airspace is 1/2 inch to 4 inches. Is going to be a 1 all day long. One. And then we have to look up the 4-inch face brick. Four-inch brick is 0.44. Is there another one in here somewhere? Yeah. Okay, so don't use the common. Use the face brick. 0.44. Okay. Oops, I got to go back over here and do this. Okay. 0.44. So let's add these up. 8, 10, 11, 12. Carry the 1, 4, 5, 6, 7. 2.72. Bam! 2.72. Okay, windows and doors are sold with a U factor rather than an R factor. If U is equal to 1/4, what is the R value of a window having a U factor of 0.44? Round your answer to 2 spaces. All right, so let's look at this. And it's very simple. R is equal to 1/U. U is equal to 1/R. Remember that the U is the speed of heat through a material. The R is the resistance. Alexa, how do you spell resistance? Alexa, how do you spell resistance?
Resistance is spelled R-E-S-I-S-T-A-N-C-E.
Okay, so the resistance to heat flow. So U is how fast it's going. All right, the speed of it. And it's usually really, really low, such as what was that, 0.44? 0.44, yes it was. Okay, so the speed is 0.44. So in order to find out the R is equal to 1 over U, which is equal to 1 over 0.44. Let's go over to their handy dandy calculator again. 1 divided by 0.44 equals 2.27. Look at there. 2.27. Good, Debbie. All right. Number 18, a wall with a 4-inch face brick, a 1-inch airspace, and an 8-inch CMU has what R value? So let's go over here and look at our 4-inch face brick. I think we already said that was 0.44. Where did I see that? Right there. 4-inch face brick, 0.44. 1-inch airspace, which is 1. And then the 8-inch CMU. Where did I see that? 8-inch CMU is 1.11. I'll get this right in a minute. 1.11 plus 1 plus 0.44. 2.55. 2.55. Right answer. Good deal, Alex. Let's see. This last one. Okay. Using the average R value from the R value table, how many inches of blown cellulose would be needed in the attic to achieve R30? All right. So average, put that in red there, of blown cellulose. So we're going to go up here to our insulation materials. We're going to look up blown cellulose in the attic. Okay, so blown cellulose in the attic is 3.6 to 3.7. So obviously the average would be 3.65. So let's go over to our handy dandy calculator and we're going to put in 30. We're going to divide it by, what did I say that was? 3.65. Yes, 3.65 equals 8.22 inches. Look at there, 8.22 inches. He didn't round it off to 2. That's okay, Paul. You did great anyway. Okay, so you still got the right answer. Okay, guys, if you have any other questions, I will go over wall insulations 2 after it closes, possibly on Monday. And I'll see you guys then.